Hello everyone, I am Ravi Shankar Pal from ABES Engineering College Ghaziabad. In this video lecture, I am going to calculate the address of an element in a two-dimensional array. This is also a random access of address of an particular element. So let's start. First, we know what is two-dimensional array and how to represent the two-dimensional array. Basically, two-dimensional array is a matrix. And if suppose there is an array A and we want to represent it like 3 into 4. So here 3 represents the number of row in a matrix and 4 represents the number of column in a matrix. Number of row this is basically number of row and this is number of column. Okay, you can also represent like m into n like this. So if you want to represent this array into matrix form, it look like suppose you start with 0th index, a 0th row, then first row, second row. There are total 3 rows. Means first row, second row, and third row, and starting index is 0, 1, 2. And here it represents the column. And if you write, start with 0 index, the 0, 1, 2, and 3. So if you want to locate the index here, this will written as 0th row, 0th column, 0th row, first column, 0th row, second column, and 0th row, third column. And here, first row, 0th column, first row, first column, first row, second column, first row, third column. Here, second row, 0th column, second row, first column, second row, second column, and second row, third column. Okay. This is the matrix representation of a two-dimensional array where 3 represents the number of row and 4 represents the number of columns. So here, what is two-dimensional array? It is also collection of same data types which are represented in the form of row and columns. It is also called a matrix. The data type is like R represents the row name, column is the C. Here I am represented row as NR, column NC. You can choose any name, whatever you want. So you can represent the memory representation. You can represent matrix or two-dimensional array memory in two forms, either in row measure order or in column measure order. In row measure order, let's start with row measure order. This is the row measure order representation. Okay. So if you want to represent in memory, it is look like if this is the array name A, and if you assume base address is 100, suppose here I am assume base address is 100 and the size of one cell is equals to 1 byte, then the next element is located at 101 and another is 102 and another is 103. Similarly, the size of this array is 3 into 4, 3 row and 4 column, that is 12. So if you start with index 0, it will look like 0, 0, 0, 1, 0, 2 and 0, 3. This is your first row. This is your first row. Second row will start with 1, 0, 4, 1, 0, 5, 1, 0, 6 and 107. Again 4 element in second row. This is second row, and the index is represented as, the second row is start with index 1, 1, 0, 1, 0, 1, 1, 1, 2 and 1, 3. Now third row, this is the third row. Third row address is 108, 109, 1110 and 111. That is total 4 location. So this is the address. Second row, that is third row means second row, 0th column, second row, first column, second row, second column, and second row, third column. So this is the memory representation of two-dimensional array. This is the third row. What is the meaning of this memory representation? Means here you can write the two-dimensional array in form of one-dimensional array. Means there are three one-dimensional array. Three-dimensional array means if there are 3 rows, then it is represented in memory like a three-dimensional array. Similarly, if array is represented like a, any I row and j column, means there are I number of one-dimensional array in memory, and each one-dimensional array contains the j number of elements. Look here, there are 3 row means 3 one-dimensional array, and each one-dimensional array contains the 4 elements, 1, 2, 3 and 4. So now we will start how to find out the address of any particular elements. Suppose here I am repeat representation of array, that is we have select 3 row and 4th column, and it is in matrix form like this: 0, 1, 2, 3. This is the column number, and size of matrix is 3 into 4. This is 0, 0, 0, 1, 0, 2, 0, 3, 1, 0, 1, 1, 1, 2, 1, 3, 2, 0, 2, 0, 2, 1, 2, 2 and 2, 3. So if you want to find out the address of any particular location in this matrix, suppose you want to find out the address of 2, 2, then here the element is represented as A22, and how to reach out this location starting from this index. So first you have to cross out the total number of elements, whatever is you have written here, that is 2, that is number of row. If it is represented as I and j, here I is 2 and j is 2, then 2 first row, and how many elements in a row? There are 4 elements, and 4 elements is nothing but the number of columns, that is 2 into 4. And how many row you have to cross? that is number of array, that is 2, plus now you are here and you have to cross two columns. This is the columns, and what is this here? J. You have to cross two columns, that is 2. Then you will reach here 2, 2. Now you will calculate. If you will calculate, then 4 into 2, that is 8, plus 2, that is 10. Now calculate. 1, 2, 3, 4 element, 5, 6, 7, 8 element, 9 and 10th. Means you have to cross the 10 element, then you will reach the element 2, 2. What is the meaning of here? Here 2 represents the array. Number of array you have to cross, that is 0, 1, 2. Okay, basically this is index. And 2, sorry, 2 array, 2 row, 0, 1, that is 2 row. And in one row, there are 4 elements. 4 elements means number of column of the matrix. This is the number of column of the matrix. Plus, what is 2? 2 is the, if you reach in this row, you cross all 2 row and reach into third row. In third row, you have to cross number of elements that represents the number of columns. And which columns are here? 2. So if you generalize this, you can simply find, if you will find the location of ith row and jth column, then you will find a formula I into, if you will represent the number of column of a matrix is NC, then it will number of column minus J, number of elements you have to cross. This is the simple formula. If your matrix is start with 0 index and one cell contains the 1 byte. In continuation to this, if you find array will represent like 1, 15 and 1, 16. What is meaning of this? This is the number of row and this is the number of column. Then how to generalize your formula? If you will find the address of any particular location, that is Aij, then you have to find out the starting index. Starting index is here not 0, this is 1. So if you will assume that starting index is represented as lower bound 1 for row and starting index for column, that is this one. This one is lower bound 2 and this is lower bound 1. If this is the general case, if the matrix is not started with index 0, it will start with any index and will start its starting index of row, that is lower bound 1, and starting index of column is lower bound 2, and last index of row is upper bound 1, and last index of column is upper bound 2. Then what will be your formula is simple. Here you can generalize this formula like I is the index minus lower bound of row minus into number of column of the matrix minus j. J is the column of the index, jth index of column minus lower bound of column. Okay, a plus base address. Don't forget to add the base address because you will start with the base address. If you don't have base address, you don't find out the any address of the element. So this is the general formula. This is the general formula. If you have the cell size, one cell size 1 byte, and starting index is represented of row, that is lower bound 1, and starting index of column is represented as lower bound 2. Similarly, now we can more generalized formula address. This is the address of any particular element located at index I, that is row I and jth column, and if the cell size is equals to w bytes, means if you generalize the size of an elements, that is if you will take w bytes, then this formula is simply first base address plus I minus lower bound of row multiply by number of column minus j minus lower bound of lower bound of column here, lower bound of row, and multiply by size of one cell, that is w. Here we have considered size 1 byte and here we consider size w byte. So this is your final formula to find out the address of any index of two-dimensional array. This is row measure order. Similarly, if you want to find the column measure, if you want to find the column measure, then your matrix in memory is representation in matrix form is same, but formula will be changed. 0 1 2 3 and 0 0 0 0 1 0 2 0 3 1 0 1 1 1 2 1 3 2 0 2 1 2 2 and 2 3. So if you want to calculate the address of this index, suppose a to second row and third column, then you will start accessing the element from column to row. This is the column representation. This is basically column measure order. Column measure order. In column measure order, you have to access the elements from row to column, right to left. Okay, right to left. So what? How to find out this element? Let start. You will skip 1, 2 and 3. That is 3 column. Means here 3 column. Multiply by a column contains the elements which is equal to number of row. That is 3. 3 plus if you reach here, then in this column you will cross the elements, that is 2 elements, that is the ith row, that is 2. So what is the location? 3 into 3, that is 9 plus 2. Means you have to cross the 11 element, then you will find the location of 8 2 3. Means now calculate 1 2 3 4 5 6 7 8 9 10 and 11. This is the column measure order. Now if you generalize this formula, like if ith, you will find out the address. If you want to find out the address of ith row and jth column, then you have to cross jth row multiply by total number of row, that is 3. If you represent the total row, that is nr, then plus what is this is 2. This 2 represents the number of row, sorry, jth row, that is j, oh sorry, ith row. Okay, plus base address. Here I have again assumed the size of one cell is 1 byte. And now again, if your array is represented like this one. Again, this is your lower bound 1, this is your upper bound 1, this is your lower bound 2, and this is your upper bound 2. Then, and if you suppose one cell contains the W bytes, you take W bytes to store the elements. So your formula to find out the address of ith row and jth column of a matrix, and if matrix is NR into NC, then what is the formula? You have to find out jth row minus lower bound of row, that is lower bound 2, lower bound 2, lower bound 2 multiply by number of row of the matrix, that is NR, minus ith row, that is I minus lower bound of row, and then multiply the size of one cell if you have assumed W bytes plus base address. So this is the formula to find the address of any location of two-dimensional array in column measure order. Column measure order. Let's start with an example here. Suppose you have given an array name is your x, and this is your row, and this is your column of two-dimensional matrix. So what is minus 15? This is lower bound 1. What is 10? Upper bound 1. 15, lower bound 2, and upper bound 2. And here requires 1 byte of storage, means so W is 1 byte. If beginning location is 15, means your base address is 1500. Then it is asking what is the location of array X at index I. At index I, this is index I, and index j means ith row and jth column, 9th row or 20th column. So what is our formula? If you want to column measure order calculation, then what is your formula to find out the Aij is equals to, first you have to base address, then j minus lower bound 2 plus multiply by number of row. Here number of row is the size of the total number of row, plus I minus lower bound 1, then multiply by W. So you first find out the what is I. What is I? That is here. You have to find out array is X, I is 9, and J is 20. So put the value from the given question base address, that is 1500 plus J is 20 minus what is lower bound? What is lower bound? That is 15. Lower bound 2, that is 15, multiply by number of row. You have to find out the total elements, that is total number is row is here. Upper bound 1 minus lower bound 1 plus 1, that is 26. If you not given the row and matrix size, then you have to find out the row and column by using this formula. So this is 26 plus I means ith row, that is here given as 9, minus lower bound 1 is given here minus 15. So this will be the plus 15 multiply by size of the one cell, that is 1 byte. So after calculation, this will be the 1654th. This is the location of an array X of index 9, that is 9th row and 20th column. If you calculate using row measure order, your formula will be I j is equals to base address plus here I minus lower bound 1 multiply by number of column, you have to skip, plus j minus lower bound 2 multiply by size, that is 1 byte. So put the value from the given question. Your value will be x, that is 920 is equals to base address is here 1500 plus I is 9 minus lower bound is minus 15, that is plus 15 multiply by column, that is column is here, column is also 26. So this is 26 plus j is 20 minus lower bound is 15 multiply by 1. So after calculation, this will be 21 and 29. This is the references from where I have taken the contents. Thank you for listening.